mutual exclusivity and independence. So while I think in a couple of days one of them will become the president, this is from some time back when they were still fighting for nomination. So I would like you to answer in the next slide. I'll ask you some events and you have to tell me which one is mutually exclusive, which one is independent, and then I'll ask you a few probabilities. Okay. So let's say the four events at that time were Trump winning Republican nomination, Cruz winning Republican nomination, event B, C is Clinton winning Democratic nomination, and D, Sanders winning Democratic nomination. Given that situation, event A and event B, are they mutually exclusive or independent? Mutually exclusive. Why? If one wins, the other cannot win. So mutually exclusive. It's simply not possible. The other thing is not possible. Okay, good. Event C and D? Mutually exclusive. Both of them cannot win the Democratic nomination. Okay. A and C? Independent. Whether Trump wins or Cruz wins the Republican nomination doesn't depend on whether Clinton wins the Democratic nomination. It's not dependent. Completely independent events. Okay. So now, assuming the probability of each candidate winning in their own party is half and half, now tell me the probability of A and B. Probability of A and B. Zero. Mutually exclusive. No? Mutually exclusive events. A and B is the superimposed part, that's intersecting part. So the intersection, not the union, the intersection is A and B, and that is not possible. Both of them cannot win. A and B cannot happen. So probability of that is 0. A or B, 1. One of them has to win. Point A or B is probability of A plus probability of B, if they are independent. Okay. So probability of A is 0.5, probability of B is 0.5. 1. A and C. .25. Any other answers? No idea what's going on? There was a Diwali in between. 0.25. What is the probability of A and B? Probability of A and B is probability of A multiplied by probability of B. So A is 0.5, B is 0.5. Or sorry, A is 0.5, C is 0.5, 0.25. The other way to also look at it is intuitively, if you want to think, there are four possibilities. A and C can happen, A and D can happen, B and C can happen, B and D can happen. Four possible events are there. I am asking for 1/4 probability. Okay? A or C? Zero. 0.75. A or C happening 0.75. What is A or C? Probability of A or C mathematically? Probability of A plus probability of C minus probability of A and C. So probability of A is 0.5, probability of C is 0.5, 0.5 plus 0.5, 1. Minus A and C, 1/4, 3/4. Or the same way, thinking about it intuitively, what are the possibilities? A, I'm not even connected. Okay, A and C can happen. So A is there, C is also there. B and C can happen. C is there, A or C, at least one of them is there. A and D can happen. A is there. B and D can happen. Those are the four possibilities. A, either A or C C is not possible only in the B and D case. In all other cases, at least that is there. So 3/4. 3 out of the 4 possibilities have either A or C included. But otherwise, the formula probability of A plus probability of C minus probability of A and C. Okay. Good. Okay, so let's watch some movies. How many of you have seen the movie Zero Dark 30? Quite a few. Okay. Okay. I'll play a couple of snippets from there, and then we will use Bayes' theorem. The movie was about killing of Osama bin Laden. So how the whole thing happened. So we will use Bayes' theorem to capture Osama bin Laden. Okay. And the whole thing was, of course, you will see it in the clips, but the US agencies had been monitoring this house in Ahmedabad for a long time, and they still were not able to conclusively identify whether Osama bin Laden was there or not. So for a long time this was just going on and on, and let's see what was causing them to not take action. Let's see this one. Havells switches. Malaysia. Okay, let's figure it out. Well, that's too much. Which one's on there again? Which one's on there? Some brother, the operator, 35% chance. Okay, so well, there are some probabilities out there. 40% probability that it is some senior Al-Qaeda operator, 35% chance. See, 40, 35, being pretty specific there, huh? 35% that it's a Saudi drug dealer, 15% it's a Kuwaiti arms smuggler, 10% some brothers, one of the brothers. 40 and 35, 75, 90, 100. Yeah. First thing that I do is add up things. Okay, they have added up 100%. Okay, so they know what they are doing. What do you think? Is it a classical approach of assigning probability, or frequentist, or subjective? Based on some statistics, please give me answers, because I end up asking accepting any answer as long as it's not crystal clear. I mean, sometimes it just depends. In data science, the best answer is depends. Okay, so I also don't know the entire script. So yeah, it could be some. They may have some 40, 35. They are saying some statistics might have gone, or it could be just subjective. They have been talking to prisoners in Guantanamo Bay in Cuba and all those things, and maybe based on many things. So frequentist probably not. I don't know. Anyway, let's watch another clip, and then we will solve problems. Okay, so now there are 60%, 80%, 95%, and they are saying that they are using it based on their past experiences and other things, detailed reporting. So maybe some subjectivity or some other information they have. Okay, but Maya thinks it's 100%, and Maya is the one who was following it up a lot, and that 129 she wrote. For 129 days, she has been saying he is there, and no action is being taken. So 4 months, more than 4 months gone, no action being taken. Why do you think action is not being taken? What are they really afraid of? They talked about Iraq, WMD, and other things. What are they afraid of in your confusion matrix? False positive, false negative. I mean, you are never afraid of true positive, true negative. That's a good thing. False positive, false negative. Those are the bad guys. Okay. Which one of them is? False positive. So they said Iraq WMD. It was a false positive. They said the weapons are there. They ruined the whole country. Nothing is there. And now they are afraid to make the same mistake again. Go and attack a separate another sovereign country. In this case, at least, that country is supporting of them. They realize, but it's a lot more complicated. So they are afraid of false positives. False positive in this case. They say Bin Laden is there, they attack and Bin Laden is not there. That's the problem. Okay, so let's use base here to try to convince. So let's say Bin Laden was equally likely to be in a compound either in some tribal areas or in that compound in Ahmedabad or in some urban area. Either in tribal area or in urban area, either in the mountain or in the city. That's it. Let's assume that. 50-50 chance. Okay, it could be anywhere. Okay. And let's say if they decide that Bin Laden is sitting in a city, in some house, that house has to have certain properties with respect to the security setup. They said, okay, the evidence that they were watching was that high walls are there. Inmates accepting a messenger for 4, 5, 6 months, only one person is going in or out, others are not moving out. What kind of a normal house will have that situation? And then people are consciously avoiding detection by satellites. Someone should really understand what is all that. Because they said when that unidentified male takes a walk, he walks under these heavy trees, heavy leaves, and so even satellites are unable to track or see. So they are carefully avoiding, they are just not able to see. Otherwise, with satellites, 1 meter, less than a meter resolution is possible. Okay. So they are unable to do that. Who would want that? So if Bin Laden is going to be in a compound will have certain properties like this. Okay. So now, if they have found such a compound, what is the probability Bin Laden is there? Okay. If Bin Laden is there, the compound will have high security features. Now there is a compound where there are high security features. What is the probability Bin Laden is there? Reverse probability. One way we know, if Bin Laden is going to be there, it's not going to be in my apartment sitting there. So let's figure that out. Okay, so and we will assign some random numbers here. Probability of Bin Laden is in compound, 50%. Probability that the compound is positive, given Bin Laden is in the compound, let's say 90%. If Bin Laden is in compound, that compound will have these features. Probability that the compound is positive, given Bin Laden is not in this compound, let's say it is 60%. Because Saudi drug dealers, Kuwaiti smugglers, or other high-ranking Al-Qaeda operatives, they may also want that. But not too many. Let's say 60%. Now, I want to find out what is the probability of Bin Laden being in a compound, given the compound is positive. Now the question is for the people in the back who are not able to see this font. Others don't read it. Can everyone see that? No, good. Intentional. No. Okay, probability Bin Laden is in compound, given compound is positive. Use base theorem to tell me the formula. Only someone in the back. In the front row, nobody talks. Probability that Bin Laden is in compound. So multiplied by probability that the compound is positive, given Bin Laden is in compound, divided by
probability of Bin Laden in compound.
Probability of
Bin Laden in compound. Plus.
We added two things. The denominator is probability.
Bin Laden in compound.
What is the numerator then? Okay. Are is the probability in the denominator, and then I will ask for the breakup. The denominator is two things now. I want the total combined part. Okay, the base here, probability of A given B is equal to probability of A multiplied by probability of B given A divided by probability of B. So the denominator is the probability that the compound is positive. Now that has two branches. Compound will be positive when Bin Laden is there. Compound can be positive when Bin Laden is not there. Those are the two branches that you will break it into. Okay? Otherwise, that's what I said. For a brief second, just think of this pipe as division sign. So probability of Bin Laden is in compound divided by probability of compound is positive. But then, okay, it is not division. It's a pipe multiplied by probability compound is positive even Bin Laden is in compound. Okay? So now let's just input all those. Probability that Bin Laden is in compound, 50% given to us. Probability that compound is positive given Bin Laden is there is also given. Now denominator, the first part is going to be exactly the same. The compound being positive when Bin Laden is there. Compound being positive when Bin Laden is not there. So probability Bin Laden is not in compound multiplied by probability compound is positive given Bin Laden is not in compound. So that is 0.5 and this is also given 0.6, 60%. Those guys were talking about 60%. Maybe they were using some kind of base here. Okay. They were assigning some probability to a compound being positive for other guys also. Whereas Maya thinks the compound being positive for other guys, that probability is very low. Nobody else for 4 or 5 months will be avoiding detection at that level. There is nobody else in the world at this point of time, was Maya's assertion. And she also said, if Bin Laden is